Okay, today I'm going to talk a little bit about how to use the framework that I just made, and I released it to Haxe lib for making extensions for DAWs. So I'm not going to get too much into the 101 of this because I think you probably are going to be a music inclined person. You probably wouldn't bother using this unless you're a musically inclined person. But just in case, I'm going to go over some of the basics, and then if you need to learn more, I would just urge you to like maybe read up some like tutorials on how to use a DAW and some tutorials on how to use like control surfaces. But in short, DAW, that is that stands for Digital Audio Workstation, is basically the main way that people make music on computers. Whether it's like very computery music where you're just using like a bunch of plugins or a combination of plugins and like synths that are connected to your computer, or even if you're just doing something fully acoustic but you're recording on the computer, a DAW can just be a multi-track recorder. It could just be as simple as that, and then it facilitates you changing the volume and the panning of each of the channels. Let me see what. Yeah, I think I got this set the right way. So this is my favorite DAW. This is Bitwig. Let me zoom in a little bit so you can all see it better. Zoom in. I don't know. Is there a general way to zoom in on everything? I guess not. Okay, anyway, so here you've got your tracks. I can hit tab to cycle between two different views. And then, so if I click this, then you have more like, this is basically what most DAWs look like. So you have track, you can just keep adding more and more tracks. And then you also have the master, that's everything. You can also have multiple buses. So you could do things like send multiple tracks through like a common effect or something like that. And typically there will be different types of tracks. This is what's called an instrument track. So instead of you storing raw PCM audio, where it's just like the actual waveform, you're storing like MIDI data and other data that's meant to go into instruments, whether it's a real physical keyboard that you have or whether it's a plugin that's running on your computer. So the track only has to store, very little data, like when the note starts and what note you're playing and stuff like that. And then like audio track is, your standard PCM audio, right? So if you think about like a traditional multi-track recorder, even an analog thing like a multi-track tape recorder, it's basically a bunch of audio tracks. It's a bunch of recording the electrical up and down of the audio waves. And then DAWs give you the ability to also do this kind of track where you have virtual or real instruments and their settings and their music data. And then there's another paradigm that some DAWs use. It may have been Ableton that was the first to introduce it. In any event, it was definitely Ableton that popularized it, which is the idea of a clip-based composition. So you can kind of do both of these techniques at the same time, but clip-based is where you have a bunch of little pieces of music. It could usually it lines up with musical measures, so it could be like 4 or 8 measures of music, or just 1 or 2 even, and it could be set to stop after it's done, or it could be set to keep looping as long as it's playing, and then it'll keep playing until you stop it or you play a different loop. And usually the idea is in a given track, you can only play one clip at a time. So you kind of switch between the clips, and then you can kind of go through and like record different little clips, maybe different beats, different pad progressions and stuff like that. You can kind of play with different combinations of it till you find something that works good, that sounds good to you. And then you can kind of arrange it where maybe the different rows represent different parts of the music. So you might be like copying the phrases around. So, and then you can kind of record that onto this timeline based view. So it's a pretty cool way to do things. You don't have to do things that way. If your DAW has a capability, you could just not use it if that's not how you do your composition. Bitwig also offers other interesting ways of composing that is kind of outside of both of these things, but in a totally different context, and is more akin to someone playing around on like a modular synthesizer or other hardware with like a, hardware sequencers and playing with the sequencer and stuff like that. There's lots of cool things you do like that in Bitwig as well. But anyway, the paradigm of using a control surface, that's also something that comes from Ableton. So what we have are things like this, basically. Except more commonly what you see is something that's just this grid, but like bigger. And then each of the buttons are more square. This is kind of an unusual one. I like it because it fits my style more. Because I can play keys on it. I can change parameters with these, and I have the clip launcher. So it's very compact and versatile and cheap. So I love this thing. What a lot of people who do this clip-based composition prefer, though, are kind of the big ones that have like a bunch of that. Some of them are really fancy and even have sliders to change volume and stuff like that. So a lot of times, which hardware you use depends on your style. But at the end of the day, most of these are very simple. Some get more complicated and have like motorized faders. That's kind of a thing that we have in the music industry, like things where the computer can make the fader go to where the volume is, so it always reflects what the volume or other parameter is. But for something as simple as this, it's basically that it sends out MIDI, and the MIDI is sent to it to determine which things are lit up. So it's really simple, and you just have to, for Ableton or for Bitwig or for some other ones like FL Studio, you just provide like an intermediary thing that that listens in on the state of the project that you have open in your DAW and uses that to send that data back to the controller. It responds to the MIDI signals from the controller and then uses that to change the state in the DAW. And if the word MIDI is confusing you, that basically MIDI is a communication protocol. I think a lot of programmers might hear MIDI and think about, like if you're my age or older, you might think more about like general MIDI. You might think about like old DOS and Windows games where the game is not playing like a raw PCM sound or playing music off of a CD-ROM, but an older paradigm where it's actually using a hardware synthesizer built into your computer to play music. That was a cool way to do things, and that's general MIDI, and MIDI bytes are involved. But usually in the music industry, MIDI is more about, I hit a key on one thing and then a different thing is making the sound. Or the DAW is storing which notes start and stop, and then it sends that real time to the different instruments so they can play in real time. So it's more of a communication protocol. I think some people, again, especially older people, might associate with like those cheesy sounds because it's a small synthesizer on a chip on computers, back in the 90s, right? That's more of a cheesy thing, but there's more to MIDI than that, right? And there's even like newer version of MIDI that has more fidelity to it. There's also another communication protocol, OSC, and I made a comprehensive framework for that for Haxe. So it's implemented in Haxe, and it works in like many different targets. Anyway, so I'm going to talk a little bit about which things that my library supports and how you might take advantage of it, and then also how you might extend it if you need to. So here I am. It's grig.controller. It's on my it is on my Codeberg. If I look in contributing, here's basically the URL right here. So grig.controller, it's on Codeberg. You can install the Haxelib that way, but I also released a stable version to Haxelib now. So that's now in Haxelib. I also added some fixes to grig.midi and grig.pitch, which this depends on. Inside of it, there's some abstract classes. There's host, which is it's an interface. If you want to make your own extension, so you have like some piece of hardware like this and it's not supported on the DAW that you like, or you want to make a version of the extension that has more features than the official version, where you start is you make a class that that implements the host interface. Oh no, sorry, forget what I just said. You don't do that. You implement something that you create a class that implements controller. Forget everything I just said about host. Host is what you need to implement if you're adding support to another DAW. Okay, but if you're just creating a script for a given controller, you can implement the controller interface. So it's pretty minimal. You just need to create startup, shutdown, and flush. In startup, it passes in an instance of host, and you probably want to store it so you can call it later in your various functions. Here is an example right here. I mean, the only example so far, other than like the samples in the example subfolder. This is like a real one that I made to support this instrument. It actually supports this instrument's the wrong word, this controller, and also its predecessor, the first version. Both are supported by this. They have different protocols, but I have the code to support both versions in this one class. Actually, this class itself doesn't implement that interface. It's just a plain class. And then I have two different classes that implement that interface, and then they instantiate it. And this isn't ideal, but it uses like an enum to differentiate the functionality. If I wrote this from the ground up, I would not do it that way, but that's just the way it is right now. So one thing you might notice is that there's a lot of metadata up here. So a lot of this metadata is necessary to make this work. You at the very least need a name. I think you need an author too. Author, version, and UUID. This just seems to be a unique UUID. And then right here you say what the device unit is for and how many MIDI ports are needed. So the old version needed one MIDI in port and one out. The new version needs two MIDI in ports and one out. It uses the different ports to differentiate the MIDI that comes from the control surface and the knobs versus the MIDI that comes from the keyboard itself. The old version didn't make the distinction. It separated them by channel. So MIDI has such a thing as channels. MIDI is just like a series of like bytes or octets, if you will. And the first byte, part of that is has information about which channel it is, like a couple of the bits. So there's like 16 possibilities. So maybe like 4 of the bits or something like that. I just think off the top of my head, so don't quote me on that. And I actually made a silly mistake in grig.midi and I fixed it. So if you're using grig.midi, please get the latest version. There's a silly mistake I made in the part of the code where you set the channel. But anyway, I digress. So you'll probably need to include maybe all of these if you're making your own controller using my framework. And then the macros in it will use that to add the appropriate data. It'll make the methods for you for Bitwig. This one doesn't do much. The constructor doesn't really do anything. And then it passes things along to this class. So this class, maybe right here, you can kind of see a lot of what's going on. Set up clip view. This file's too long. I'm not proud of this file, honestly. No, startup is the word. Here you go. So the way I have a lot of things is because there's uncertainty about the timing of when, about both whether a piece of functionality is there in a given DAW or not, and two, about the timing of it. So I use a promise-based interface. So here's an example. The first thing I do after storing, my own pointer to the host object is I try to create controller settings. So if it succeeds, then I call init settings, and then that creates all the settings. All the settings like I'll show you some examples. So if I go into controllers, these are all settings I define in that Haxe code. So I can change what pressing Shift plus record does. I can change what doing Shift plus play does. Like these are all cool features that aren't in the official Bitwig version of the script for this. All of these are using this setting API. So this doesn't have to be there because it's not really, it shouldn't be seen as an error for failure to happen. If failure happens, that just means that this feature is not there, so you don't use that feature basically. And that's the way you should think about anything that in this library that returns a promise. It's not that it failed, it's just that it's not there. It could be in some circumstances that it could fail or not, but more likely failure means the functionality does not exist in this for the given DAW. Now again, for now, the only DAW that is supported by this interface is Bitwig. But my hope is that I won't have to change the interface too much when I hook up additional DAWs. And then, here I'm just kind of instantiating some data. This calls another function that sets up some callbacks. Here's another one, asking for a transport. So transport represents like playing, stop. It's like an object that lets you play and stop and stuff like that. So if it has a transport, and almost every DAW is going to have a transport, I think like the most minimal support might be for some DAWs that only have a transport and nothing else. Don't have the clip-based interface. Don't have, maybe don't even have like a settings interface. Probably there's always going to be a transport, but I still make it so that it could potentially not have that feature. So here I just set the transport so that I can hook up like, this play button to, play and stop and stuff like that. And then clip view is basically representing the, using the squares to show you where the clips are for the clip launcher. So they will be different colors depending on which clips are present or not. And I'll show you what that looks like shortly. So there again, the feature may or may not be there. And I even have a fallback here where it creates a track view instead. So some things might not have a clip view functionality, but they might have track view instead. In that case, you can still do some of the things associated with this. So there's a lot of cool things like that. So I would just like look through the host API for whatever you need for your controller. And then get MIDI in, you pass in like the port, and then what you get out is like a MIDI in. This is the same as like grig.MIDI, MIDI in. It has the same interface, so it could be used the same exact way. I even have like I said, the only DAW supported is Bitwig, but I also have a standalone version, and that's gonna support just directly accessing your hardware MIDI and stuff like that. And then here we have get host MIDI out. So this is where you can actually send MIDI to the DAW. So this is how I'm able to do cool things like making it so that the clip launcher gets into a different mode where it's like a keyboard and you press keys on it. Then it sends like a key or even an entire chord at a time. That I'm able to do because I have this. So this gives us another, a grig.MIDI MIDI out device that you can keep and use just like any other MIDI out device, right? So I'm kind of, referencing to my other abstractions that I already have. That kind of leads to more code reuse that you can do in this space. So I think that's all pretty simple. Like I'm not walking through the whole process of starting one from scratch, but now let's kind of look briefly at some smaller examples that are in the repo that might also help to look at. So here in examples, I have two things. I have minimal. This is an extremely minimal extension. All it does is it just spits this message out to the screen. So this is almost more about showing that it can compile, and it provides like the minimum necessary of the metadata to compile. Another one that's kind of interesting though is the Bitwig test. This shows how you can actually make a Bitwig controller without using my API. So you can follow the instructions in the README about how to get the Bitwig Java libraries, and you can just directly use that in Haxe. So you can just directly make a Bitwig extension in Haxe, and you don't have to use grig.controller at all. You can literally just use the Bitwig API, and using the instructions that I have, you can actually get like a nice a documentation HTML of the Haxe externs for that. I didn't have to make the Haxe externs by hand. One of the cool things about the JVM target for Haxe is that it's automatic. And I wish that there was an equivalent of that for all of the targets, because that is so awesome. Like the Achilles heel of Haxe is having to make your own externs by hand. It seems magic until you realize that you have to make externs usually. In this case, though, all of those Java classes and everything, they're available in Haxe right away, and you can just use them directly. And if you look in my code in grig.controller inside of Bitwig, here's where I make the Bitwig versions of all of these interfaces. And here's where, like in most cases, I have like an instance of some Bitwig object, and I'm just wrapping around it with like another thing. So you can see how this is, it's okay, so I just happen to be in the one for like a setting that wraps around an enum. So this calls, so the value member, that is a Bitwig object. Right here, we're calling methods on it, add value observer, and then I'm passing in just a inline function basically that's wrapped around like a class that has like a function inside of it, whatever. So there's like a bunch of like these little things, and here's my implementation of host. Here again, we have really just one Bitwig thing that I'm importing at the top. I have an instance of that, and then we're wrapping around that. So it's pretty, in principle, this thing is pretty simple. It should be pretty simple to use and to add features to it. So you can use my abstractions, you can skip around them and just use Bitwig API directly. I also have some code that I stole from someone. So Jeremy Mellingtallow, I don't know if he's doing anything in Haxe anymore. I don't see anything of his on GitHub for years. I think he's working for some company that's just and not doing anything for them in GitHub. But anyway, I haven't seen any public Haxe-related activity from him in a while. And I think he even told me like a long time ago that he's not working on this code anymore. So I just imported the whole history into my repo, but in a subdirectory. And the only thing I've really changed so far is I just changed the namespaces so that it sits inside a grig.controller. And there was like maybe one file that I deleted because it was like something he started on, but it was just a copy of something else and he never used it. So, and that got in the way of me making the docs. So this is something that you could probably tap into this directly to make a Lua based script for for renoise. So renoise doesn't have the clip-based paradigm, but I have a theory in my head that I might be able to reuse the same grid controller to do like their tracker interface panel. I'm not sure if that works, so I have some ideas in my head, but it might not actually work out when I try it out, but we'll have to see. But in any event, you can just directly use this part if you want to make something um, for a renoise, but I'm going to use this to make a wrapper around this, just like the one that I made for Bitwig. And the biggest thing that I actually had AI help me with the other day is make make a dummy implementation so that I can use it for tests, so that I can test things that use these interfaces basically. Um, I think this mostly works right, but there's some weird decisions that it made, and the AI clearly doesn't understand like what this is. I mean, it doesn't really understand things anyway. But I cleaned it up and got it good enough to be worth checking in, and that's going to help me with starting tests. There's also some stuff I did this by hand, but I made my own. Uh, I made my own dummy versions of some of the Bitwig API, and that's how I started to make some tests because there's like a bug that I found in some of my Bitwig wrapper code, and I figured that making these things is a good way to test the logic of the wrapper code. So I think down the road I want to do more and more of this and ultimately try to get to full test coverage. When I started on this, I had the mentality that this does not lend itself to automated tests. And I'm big on making automated tests, even for weird things that don't make sense to automatically test, like audio output and doing fuzzy compare. But somehow I didn't think of trying to do stuff like this until recently. But so I started doing that. This I did by hand. I think the at least the state of the particular AI I'm using it might not have gotten that right because it even made a lot of weird decisions when I had it make the dummy version. In here, I had to fix up a lot of things. It's not the one. It's not the models that everyone's um, raving about, though. It was a free model. That might be part of the issue. Um, might also be that I didn't have things documented well enough. Anyway, so now I'm going to talk a little bit about adding support for a DAW if you want to do that. I kind of already mostly covered that, but basically what you want to do is make a subdirectory in here. If you want it to be in this repo, you could also just make it in your own repo, right? Like you could even, one cool thing you could do is you could make a thing for like a game and then turn existing controller scripts into something that can help you control in-game audio assets or something cool like that. So you can even make something for like a bespoke thing. But if you want to implement something in my repo, then you can just create a subdirectory here, just like there's a Bitwig one here. And at the very least, what you need is like host. You need to create a class that implements that, and then at the very least, create implementations for all these things. What you also might need to do is provide, let me think about this. So generate, controller. And then you might also need to do some macro magic, just like I did for Bitwig and for the standalone version. I just want to like double check a little bit before I tell you the right thing, because I said the wrong thing before. So make sure I don't do that again. So controller generator. Okay, here we go. Yeah, okay, so we have like kind of a generic macro that's run pretty much no matter which DAW you're targeting. And then I have some this might not be the ideal way to do it. I have to maybe rethink this a little bit, but there's a little issue in Haxe where macros can't call other macros, and that's not necessarily an issue because you can like directly call you could share functions between macros, of course. But this basically uses like it uses the define. That's how it determines which type of script that it makes, and then it additionally calls that version of generators generate on the fields, and then does additional stuff. So Bitwig has its own stuff that goes through, and then it makes functions that return that data. I mentioned that before. And it's mostly just stuff like that. It does stuff to turn like that data that you provide into functions that Bitwig's interface requires. And there's a little bit of that for the standalone too, but that's more simple. You can even like look at that here. It's the standalone version creates like a main class. And then I think the final thing I should talk about is how to actually build this. And this is the part that's not streamlined yet, and I need to think about how I want to streamline, if at all. But basically, you need a different approach depending on what you're building. And currently, again, you're probably just building Bitwig if you're using this until additional things are added. So you need these libraries. So basically, I have a full example in the README. This is basically everything you need. You need to call this method, and this will get the latest version, actually second to last version of the Bitwig API. So 25 only works with Bitwig 6. Let me make sure I have that right. Come on, what version is this? Oh, there you go. Yeah, this is version 5.3. So this is the latest of the 5-point versions. But Bitwig has version 6 in beta. So the absolute latest version of the API is 25. I'm using 24 here. You can use a different version if you want. Honestly, this same code seems to work with very old versions of it. And I don't have a facility in here to let you specify the version, the API version that you require, but maybe I should, because basically if you're only using certain features, you can have backwards compatibility going way back. And because Bitwig is like a subscription-based thing, a lot of people are on like much older versions of Bitwig. There's also like, a lot of times hardware comes with like a light version of it, like 8-track or 16-track. So a lot of people will have those, and then they don't renew when it expires. So I think you want to make your controller work with older versions. So it might make sense for me to look into having ways where you can specify the version yourself. Right now it's just hard-coded to 24. I definitely didn't want to force people to use the absolute latest version, especially when I don't even use that myself. I don't want to use the experimental version on my music, But this is like the Maven command. You need to have Maven on your computer. I never deal with Java stuff. This is one of the few times I even touch Java is dealing with the Bitwig extension API. But I am very impressed with Haxe's Java support. I did find a bizarre bug though, but whatever. So use Maven, you download this, and then this basically all of this replace the all uppercase things as appropriate. Need to go into your HXML, and then ultimately what you're creating is a Bitwig extension. It's actually a jar file, but you rename it to BW extension, and then that's loaded as an extension. Bitwig supports controller scripts that are just JavaScript, but it also supports Java jar extensions. I actually initially tried to use Haxe as a way to generate, like the very first version of this controller script I made was just in JavaScript. Basically, I bought this old version a long time ago when Bitwig was still really new software, and it of course didn't have support for this. So I really just spent like an afternoon and I whipped up the script in JavaScript. And that worked well enough for a while, but eventually I just didn't like the maintenance headache of like a deterministic script. And I tried to use Haxe as a way to make that JavaScript. But it's a weird dialect of JavaScript that uses the Java objects rather than the standard objects that JavaScript usually uses. So it's not like the JavaScript you get in the browser. It's a weird Bitwig flavored JavaScript. I see some people out there try to use TypeScript to make that, and I think those people should just use Haxe with even if they don't want to use my thing, they should do what I mentioned and just use Haxe with a Java API, and then it's like probably anything they like about TypeScript but better, you know. Anyway, and then I ended up ultimately rewriting that thing mostly to use my framework. Um, and what is my point of talking about that story? I don't know. But anyway, Bitwig supports Java-based extensions, and that's cool because Haxe is good at making JVM. It saves you from the tyranny of Java. And I think it's cool that we can kind of take advantage of this as a way to let you reuse the same exact code, in theory anyway, once I add the wrappers for other DAWs in multiple different DAWs. I think I'm going to close by actually showing you this in action because it's been very abstract. You don't see like all the colors and stuff. So I'm maybe just going to open a lot of these don't sound very good. Let me try this one. What does this sound like? Oh no, this one is no good. There's too much missing crap. How about this one's just me playing with samples. Okay, so here's what it looks like. You get like different colors. And then once something's playing, it's a different color. You can't really see that, but see, it's like green. And then also I added a feature where I could do shift and then sustain. I could get a keyboard. Let me hook up another keyboard. Something obvious they can hear, like an organ. Then I also made, this is like a scale-based thing, so let me stop this. Use the stop button to stop it. And then I can even change the key. You can see that on the screen. I can do shift and then put a key, and now I've got like a, let's do mixolydian. Okay, C minor, how about? And then I have another version that looks the same, but oh wait, actually, hold on a second. I did it backwards. There you go. Each one of these is a whole chord, all in the scale. So this is functionality that doesn't come by default on all those Bitwig, on all the controller scripts that come with Bitwig or that the manufacturer provides. Same with Ableton Live, but now thanks to this, you can kind of add more things like this. This is just the regular keyboard. You know, really simple stuff. And then, you know, all these like knobs can do different things depending on which mode I put it in. I could set it to like the device, and then now I'm like changing the parameters on the device. You can see that on the bottom of the screen down here. As I turn that, it's changing those things. What's cool about the new version of this device is it's a continuous controller. The old version, for better and worse, is like an old-fashioned like a hard stops at both ends kind of a controller. And the old version only has like two colors, green and red. This version has like, it actually is like unlimited colors, basically. You can actually use sysx, that's like system exclusive MIDI, to set the RGB actually. But the default way is you use the channel to set the color, which is a weird way of doing things. You know, channel's supposed to segregate things so that they don't get mixed up, but this actually uses channel to tell which color to use, because velocity is already used for a different thing. Velocity is used to like for if it's blinking or not, or if it's full strength or faded. So it uses channel to determine the color. So there's like 127 color values to choose from, but there's even more again if you use sysx. If you're not familiar with what sysx is, that's like part of the MIDI standard where you can send signals that are for a specific device that only that device is going to understand. So you don't have to use like standard things like note on and control change. Okay, so I think that's it for today. Like that's hopefully this is useful for like the 2 people on the entire planet who've ever wanted to write DAW extensions in Haxe. But hopefully it becomes a bigger thing. I think I can make just like the Linux desktop. This will be the year for people using Haxe to do music stuff. Anyway, peace out, y'all. I'm gonna see a. Speaking of music, I'm seeing a concert tonight. SRSQ. Okay. Bye.